Very beautiful to all. Today we are going to discuss a case study topic on guidance and control in a kit. It's like an aircraft what we are having control surfaces. In aircraft we are having control surface means we can have a maneuverability to how the aircraft to go in a direction towards right or left, as well as to move up and down. That is called pitching. When you go left and right, that is wing goes left, and for left hand side is going upward action. The wing rolling, that is called a rolling moment, and another one is called a direction change. That is called that is the responsibility of yain. It is depth is the so like that. There's the control surface are here in the aircraft. Same phenomena you are going to apply on rockets. How you can be controlled, as well as the guidance systems. So those kind of things as a case study point of view. Our mates of the being here with from the third year aerospace engineering going to discuss and the guidance control in rockets. Okay, and now let's start with one by one from Metis side.
So now let me discuss about guidance system and guidance and control system in our needs. So guidance system, the main purpose of BABMC guidance system to ensure project reaches a correct destination along. It prevents the current destination to prevent mission failures. So the best example for a guidance system ISRO's PSLD2 is most KSM. For the main reason, it has a better reliability to control the vehicles. So it has a three main points on guidance and control, and guidance, navigation and control. So guidance for current path, navigation for motion, and controls systems using here. So all three only together like the brain of the methods. Let me continue with the guidance system working process. So how this guidance system works in the sense, usually as aircrafts and spacecrafts will have manually control and ground station. This guidance system act from a ground station control. The rocket's path will be simulated along with the space atmospheric vacuum data that is acquired from the previous jets and space missions, and those data will be fed into the simulation software. That simulation software imitates a rocket's live motions and rocket's live working conditions. And if the rocket path and the simulated data will be along with that simulated data, the rocket's path will be decided and planned accordingly. So if rocket's path is changed or any mistake, any wrong path rocket chooses means the corrections data will be sent to the rocket control system, and the rocket will control its path automatically. This is how the guidance system works. This rocket's path is rocket work along with the gravity's pull, so that the fuel consumption can be reduced with the help of the gravities, and low fuel is used, and the guidance systems helps the rocket in like that. Right.
And I'm going to tell about a navigation system. In navigation system, we provides and tell about the system where is in our situation, and PSNB it is done by the inertial system, and it has the sensors like gyroscope and accelerometer, and the navigation system is provides the motion and speed of the rocket at all situation every time. By these data, we know about the rocket, where it is in which velocity it is like. So we can know about that, and these data are continuously sent to the onboard computer, and the onboard computer is calculate the motion of the rocket in which is measured, and in rockets the system is used without any external signals, so it is more reliable than other, and so the gravity system is mostly used to know about the motion and speed of the rocket. I'm going to talk about control system. Control system makes sure the rocket moves in the correct direction.
If it not, it corrects. Then in PSLE they use thrust vector control, which means the direction of the engine thrust is changed, slightly changed to 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 ensure the rocket is going in the correct direction. So this is built in PSID, and these corrections can happen very quickly because there is a small error. The mission will be failed, so it happens very quickly. This is how control systems is in.
So I am going to speak about the several challenges in the control systems and tracking navigations. So there will be several errors in IMUs, and gyroscopy will give the errors in velocity position of the vehicle. Even the minor error can lead to the major destructive damage to the vehicle. So it is like a butterfly effect. So many often speak about PSLD, the workhorse of India. Even though it is very reliable, the past two launches were not very successful. It has been lost in the two or third stages of the missions. So to reduce that, we have to make robust algorithms, have critical sensors which should handle high temperature and pressures. So by using that, we can reduce the damage and deviations.
We know about what are the types of sensors being used for guidance and control for the tests?
Mainly temperatures, then diverse questions. Acceleration
Accelerometer for what purpose it is used?
acceleration of calculate the velocity also.
Then what about the where it exactly the rocket? There is that is navigation. Where it is there is a GPS, no?
Use the signal reducing violence and reduce violence and support. Navigation shows that direction. Swimming in space, that's more successfully a GPS service. What it happens is the data from the space will be fed by software, and the software sends the same space atmosphere in a digital way. And on that digital way, the path will be fixed and decided for the rocket's path. And they will think noticing the rocket's motions changes with comparing it with the similar motions. And defending path deviation occurs every similar scales versions. What happens is a similar base software denotes its on and where corrections will be sent from controls downstation through rocket controls and it will direct analyze. This is how actually it is also known as perimetry and radar sensors.
Okay, it's a nice interaction from your side both the guidance and control and rockets of a case study point of view. We will meet you in next class with a different topic. Thank you.
Maybe.